Uh, Warm greetings and a very good afternoon to all the dignitaries. Foremost, I would like to thank Dr. Purvan from 3R Waste for giving us this kind of a platform, and of course Waste Netherlands, Finnish Society, and of course the Dutch Embassy. My topic today is Dugapur Biogas Plant and innovative work in the FSM sector. This is just a brief outline of what it is all about. But above all, just a year back, we happened to be in Dugapur, and we were asked to provide a solution for management of waste, how effectively we could manage. And undoubtedly, it's not just the dynamism of the Honorable Chairman, Shri K.K. Gupta, but we had a very dynamic team, Mr. Vikas, Lokesh, and of course, Lokesh Junior and Rajneesh, who were there 24/7 to take rapid decisions. That is how we could make it success. So it would be futile if I don't acknowledge them. So the basic inputs that we initially received was, it has a population of around 55,000 with 30 wards, and the total waste generation was around 15 TPD. And of course, there was a very good door-to-door segregation, which was partly managed by the Finnish society also. And of course, they were really proud because they happened to be one of the first cities in India to go open defecation free. So that was really kind of a very thrilling task for us also when we ended in Dugapur. But then there were certain objectives which had to be met, is because the initial data what we got was management of the wet waste was around 3.5 TPD. And then, whenever you are supposed to manage a waste, it is always advisable if you have a large quantity along with you. So we asked them if at all we are able to garner any more waste. Then there is a Goshala which is adjacent to the site, which houses nearly 100 to 125 cattle actually. So we expected another 800 kg of cow dung there also. But still we were kind of hungry for more. And then eventually we asked, is there something more? Then finally, I asked, what do they do about the fecal sludge management? That is when they said, it is right now being dumped into the open sites. And that really kind of a blessing in disguise for us is because, they happen to be one of a very good culture for management of, bioremediation also. So we assessed various technologies, and eventually we decided we have to have a very effective technology that would be a biomethanation plant. And of course, when we visited the city also, there are beautiful lakes, and one major thing which not only, Surat where I belong to, but major cities are facing is about the water hyacinth, which have more than 10 times water evaporation rate compared to the conventional sun's evaporation. So of course, keeping the lakes clean and getting again the water hyacinth also as an additional fodder for the biomethanation plant was again a blessing in disguise for us. And when we visited the site, of course, they have a micro-composting site, and there was another emanating from it. So we thought, okay, ultimately, if we go for a biomethanation plant, this would definitely yield a better result, reducing the odor also. So when we sat across and thought about the design, then we had to take the future prospect also, so that the remediation is proportionate to the growth rate for at least for the next 5 to 7 years. And not only that, it should yield more output for the other extra utility than for the captive consumption of the plant itself. And of course, since septic was going to be one of the ingredients which was going to be fed to the digester, then the treatment of the slurry out was also one of the challenging thing. So, and of course, one major thing is because this being a small, Nagar Parishad, there were constraints regarding funding also. So we had to build it at an optimal cost so that we could yield a better return on investment. So what people view normally as a biomethanation plant is a well, and we redefined it as well to wellness. This is a path, right? So if at all, without going into much of the details, because everyone is aware about a biomethanation plant, but if at all I were to talk about the salient features, I would rather say that this is the first of its kind of biomethanation plant that treats all kinds of biodegradable waste. The first of its kind, again, it's a 41 feet diameter, 12 ton weight floating dome type of a digester. And the best part being is that the construction cost is 90 lakh rupees inclusive of 2 years of maintenance, and the gas generation is around 450 meter cube per day right now, which means that per meter cube construction cost is coming to 20,000 rupees, which is less than 50% to 60% of the conventional biomethanation plants which are developed in India. And one more salient feature is that the appliances which are needed to run the entire plant is just 22 HP, of which 15 HP is used for the crusher and the grinder system, 3 HP is for the slurry mixer, and of course 2 HP is of the water pump. And the revenues that can be generated out of the sale of compost and liquid fertilizer is expected to be around 38 lakhs, which we can start seeing the results from next month onwards, which virtually means that a return on investment is less than 3 years, which is higher side, which I have kept it around 3 years. Now if we were to do a pure exergy analysis, like what is the available energy that I have in the end, we can see that this is a very highly effective model, because out of the 450 meter cube which gas that is being generated, 44% of the power will be 44% of the entire gas will be utilized for the captive power needs by using a 30 kilowatt generator, which will be running all the electrical appliances of 20 HP for 8-hour shift. Which again we are still left out with close to 250 meter cube of gas, and of which 50 meter cube will be tentatively being utilized for the pasteurization, for treatment of E. coli and other pathogens through a system which will be employing a boiler which will pre-treat it at a 75 to 80 degree temperature for 1 hour. Of course, we have a small 3 kilowatt generator that will be put to use, which will be consuming nearly 30 meter cube of gas, which will be able to energize 250 LED bulbs of 10 watts each. So the entire night electrification will be taken care by the small generator, and of course the remaining 38%, of course we cannot bottle it, because bio-CNG option is not a viable option for smaller plants. So in this case, remaining 10 kilowatt hour electricity generated will be fed back to the grid. So that makes it a highly effective model. The next, this is what is the 360 degree of the site which was there a year before, and this is the Gaushala. As you can see from here how it appeared, like fully of bushes and shrubs, and this was an open dumping site earlier, and this is what is the plant right now. The crushing unit includes slurry mixing and the gravity flow outlet. So if we were to assess the feed statistics for the 18 weeks of operation, the feed data, it's like more than almost 360 tons per have been fed so far, with 51 tons of each septic and cow dung has been fed to the digester. Nearly a small quantity as of now we have received is for the water hyacinth. The dome lift is 7 feet and the gas generated is 450 meter cube. So if we were to assess a feed trend, the average feed rate so far has been 3.5 TPD. Whereas the feed rate peaks from 6.5 to 7 TPD depending on the festive seasons. Balancing the feed rates is highly essential for the proper working of the plant. But one significant aspect that we could see, that for smaller towns, the septic feeding is not a day-to-day affair. Initially when we were said that you will be getting close to 2 tankers, that is almost 6,000 liters of fecal sludge a month. But later on we got to know that it is around 400 tankers on an average throughout the year, of which during the winter season we can expect close to 150 to 200 tankers. So I think it is the right time by now when we start receiving more of the fecal sludge which will be fed to the digester. So if I were to summarize, for small towns up to 15 TPD wet waste, a population up to 2 lakhs, the ideal technology is an integral biogas plant for remediation of all kind of biodegradable wet waste. Ideal proposition for management of septic waste, since emptying septic tanks is not a day-to-day activity. Investment behind such projects is less, return on investment is faster, high scope of local employment generation and a higher yield of organic compost. Right now we have got close to 5 to 6 people who are working, but once we start to have the slurry out and we start the composting part, this will give an additional employment generation of 12 to 15 people more. The gas generation is not only used for the plant's captive needs but also for the other thermal and electrification purpose, and the conditions would be highly suitable for a bio-CNG plant for towns which have more than 15 TPD wet waste, that I am talking about close to 800 meter cube of biogas generation per day. Then only the cost revenue factors would really match for bigger towns which have more than 15